Greetings! It's me, Unofficial Dip, your favorite space cowboy. How can I be a space cowboy, you might be saying? Well, the answer is quite simple, actually. I wrangle code, which is kind of similar to wrangling cows, I guess. And I've got a spaceship as well. It's called the Earth. Anyway, let's get into it. What are we talking about today? This is just the playlist I'm using right now, if anyone was interested in the music. But we're talking about money. What is money? Money is money, obviously. Yeah. Right. We use money to buy stuff, sell stuff, buy services, and we all need money. Well, if you're alive, you need money. If you're dead, then you don't really need money. And here I've got a quote from the Bible. I'm not really a religious person, but I thought it was pretty cool because, you know, it's related to our topic at hand. And the quotation goes a little something like this. For the love of money is the root of all evil. Very ominous. What does that mean? I don't know. But it often gets shortened and, you know, a bit misquoted as just money is the root of all evil. In that case, you can call me a saint because I'm in a lot of debt. But enough about my financial troubles. Let's get to it. What are the methods of earning money, my friends? Well, the obvious one. Let's get a job. Get some skills, get a job, get paid a flat hourly rate, right? Unless you're working sales in specific positions where you can get commissions. But regardless, we're not talking about that because I don't think, unless you are working a job with commissions. But anyway, jobs are cool. You get a flat hourly rate, HR. Nope, no, not that. Money per hour. There we go. Or maybe you get a salary per year or whatever. Or, split over a month. Anyway, jobs are cool. You get money. It's very cool. You get taxed on money, and you get taxed again when you use the money, which is kind of cringe, but enough of that. I think that's rather a bit inefficient for my my case. So what can we do? Well, we can maybe buy assets. And what are assets exactly? Well, let's have a look. Investopedia says assets are a resource with economical value. Just means we can buy it with money and sell it for money. It's very cool, right? That an individual, corporation, or country owns or controls. So in this case, we're the individual, so we can control it. Let's go. With the expectation that it will I'm stuttering, kind of a bit nervous. With the expectation that it will provide a future benefit. What are these benefits? Well, sorry. I don't know, maybe if you're buying stocks, you might get dividends, which is pretty cool. Or maybe just if you're holding into something else, maybe let's say crypto or property, you want the value of the underlying asset to go up in price. And that's good, right? Unless you're a new home buyer, then it's not good. But no matter, we're not talking about houses at the moment. Crypto. As an avid novice programmer, I like coding, and that's probably the most in reach of me at the moment, right? It's the closest thing I can do. So I thought, hey, why don't I create my own cryptocurrency and show you the steps that I took to get there. Technically it's not done, but we'll brush that off for now. So let's start with a simple overview of a blockchain. What is a blockchain? Well, this is a description from IBM, which states that a blockchain is a shared, immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. What the heck does that mean? To simplify, let's have a look, word by word. Blockchain is a shared, so anyone can access it, right? It's shared. If I share it with you, you can see it. I can share it with anyone else. You can share it to me, no one else. So it's shared. And it is an immutable ledger. So what does immutable mean? Immutable, this means you can't change it once it's been created. So once you've created the ledger, it's there for good. You cannot change it. It's permanent. That facilitates the process of recording transactions and tracking assets in a business network. Right. So transactions make sense, right? If we're using cryptocurrency, so we're going to make a lot of transactions. We want to buy stuff, we make a transaction. Tracking assets in a business network. I guess in this case, our assets are the cryptocurrency itself, right? there's a different definition as well, which I've gotten here from Investopedia, which states that the blockchain is a digital database or ledger that is distributed among the nodes of a peer-to-peer network. It's a bit more in depth in terms of like the actual framework for it. So let's break it down even further. A digital database. That makes sense. Cryptocurrency is all digital, it's all online. That is ledger that is distributed among the nodes of a peer-to-peer network. So what are nodes? Nodes are, well, just any user, basically. So I'm a node in this case. You're a node if you use cryptocurrency. Anyone else is a node if they own cryptocurrency. So that's what it means. Peer-to-peer just means, person to person. So no need to worry about like a big server, like multiple servers and stuff. So it's just peer-to-peer, like person to person. Alrighty. So now we've done the explanation for the the backstory, the all the information that you need to know to get this little bit of dialogue. Let's get right into it. So this is what I've got right here, and this is a okay, it might be a bit daunting, but let me just just break this out a bit so I can just start from the top. This is a file that I've created following a tutorial that I'll link in this post. So if you're interested and you want to make your own blockchain, feel free to follow that tutorial. It's pretty helpful. And I've been referencing it for this little project. So what you do first is import any encryption algorithm of your choice. For this one I'm using SHA-256, and if I'm not mistaken, it should be the same one as Bitcoin. So that's cool, right? And what can we do with it? Well, we'll get to that shortly. But let's have a look at some of the stuff that we've got right here. Made some functions such as update hash, which is cool. What does it do exactly? It takes in some input and makes like an empty string here. That's cool. And it initializes a SHA-256 function. And for args and arg, so like anything that I input, it adds it onto the string. So in this case, something like if I did update I should probably comment this out. Yeah. So if I put in update hash A B, then it would grab those two arguments and then stick them together. So we get something like a B. Ta-da! Very cool, right? And after that, it'll encode it. It'll do some formatting stuff, and you don't have to worry about it too much. And then it'll, run the hex digest, which is pretty cool. It just formats it in a way that we can use it with the SHA-256 algorithm. All right. So if you didn't get that, don't worry about it. It just does stuff. No, like we don't need to worry about it too much. But what we do need to worry about is the block class, the block and the blockchain. So I guess I'll start from the blockchain first, since I've already introduced it. But what is a blockchain? And as you have seen here, it's just a database, and it's a distributed database, so everyone has access to it, and it's immutable. Once it's made, it is permanent. You cannot change it. And yeah, let's see how we've implemented this. We'll skip over difficulty for now. Don't need to worry about that, but here we go. So define init. So what is init? It's just our initialization of the blockchain. So anytime I call blockchain on its own, it'll run this bit of code. And what we have here is just self.chain equals chain. And what is chain? It's an empty array, which is pretty cool, right? Well, we haven't done anything yet with it, but we can start adding on stuff to it after. Like right here. Oh my god, what a coincidence. Define add self, block. Self.chain append block. What does that do? If I were to add a transaction, so if I send you money or you send me money, then that'll count as a block. Sorry, let me just turn this down a bit. That'll count as a block, and we can add it to the chain. And anyone can access that, by the way. So once we've added the block, it's permanent, and anyone can see it. That's cool. And if you want to remove a block, then I guess you would do it from here. But I don't think I'll be using this one a lot because this is... Actually, I don't think this is meant to be a functionality, but I'll just leave it in there for now. And what you can do now, after that, is have a definition of a function called isValid. And what does that do? It just checks that everything is in order and that the blockchain doesn't have any bad actors trying to, disrupt with the normal functioning. So the logic will make more sense after I discuss what the other classes and functions do. So I'll come back to this later. Now that we've discussed what a blockchain is, let's go over to a block. What is a block? Well, it's just a transaction, right? So if I send you money, or you send me money, that gets encoded as a block. And a block has a couple of things that is associated with it, such as the data. And what would the data be? Well, for our case, since we're doing a cryptocurrency, it would be, maybe the sender, maybe the person being sent to, the amount of cryptocurrency being sent, something like that. And a hash. Alrighty, so this is where it gets a bit more complicated, so stick with me here. What is a hash? Well, hash is for this case, it'll be just a piece of string, okay? Just think of it as a piece of string for now. And we've got a nuance, right? And why is it called a nuance? Why do you say nuance and not nonce? Because it is actually n once. So it's n as in a number, they use once. Hence n once, n once. That's pretty cool, right? Now, what do we have after that? Previous hash equals 0, string 0 times 64. And this is more of just a formatting procedure. Since this SHA-2256 function here always outputs a 64 length string, so this is just making it so that it's easier for us to to validate later. We got that. Now if you want to initiate a block or a transaction, this is what we do. We put in a number, and by default it's 0. So if we just initiate a block, it'll start with 0, and I'll just put this data as itself. Sorry, the data from this function. So if you want to create a new block, you would have to do something like this. So let's say this is new underscore block equals how do you do it? Block with capital B, block, not block. Block and self. You don't have to do anything. That's just for semantics. You need this to be able to assign data, so don't worry about that. But data could be anything like I don't know, tip sends my good friend Tole the cat to I'm not too sure. I don't know what do we call it. What do we call our cryptocurrency, guys? Corn cobs. I send 2 corn cobs, then I go comma number 1. So if I do that, this will be the data. It's right here, and this will be the number. So the first, actually, I should probably do 0. 0 is like the first. These are programmers. Haha. So that'll be the new block. That's how we define it. And this just puts it into the self.data field and self.number field. Now I've got a hash. What is a hash? Well, it returns something called an update hash, and I think we've seen it before, but we haven't gone through it yet, so I'll lay off on that for now. We've also got a define string function. So if anytime we try to print it, it'll, instead of just printing the actual block, it'll print out something like this that we've put up in a format that is a bit more readable. And how does that work? Well, we've got something about blocks, something about hashes, about previous data, and once, very long. But it'll make more sense once we actually run the program. Now, let's have a look here. What have we missed? Oh yeah, mining. So what is mining? Mining, well, it's something that a computer does, right? Computer mines for us once we call this function. And let's see what it says. Try block.previous hash equals self.chain -1 hash. I wonder what that means. And accept index error pass. Very interesting. So, for the hash, here we are. Control F. I believe we've set a hash here somewhere. Yeah, here we go. So, for the first time we create a block, it'll have previous hash as a 64 length string of zeros, right? And what does it say here when we mine? It says, oh, sorry, block.previous hash. So the list of 64 zeros, right? The string equals self.chain -1.hash. So self.chain is just, as we defined before, just the chain from the blockchain right here. And -1 just means it'll go to the front of the chain, right? So the latest one, the latest item that's been appended to the chain. And .hash just gets it. This gets its hash. It just computes it. If we look up here, should be able to see it. Yep. Define hash. Yeah, so if you call hash, it calls update hash, which does something else. Hold on. Yeah. So this is where it runs the hashing, the update hash function to get the hash for the corresponding arguments inside the function, right? So it does that, and it compares the, hold on, yeah, compares them. Sorry, it doesn't compare it, it equates them. And if the index is an index error, so if it's out of the range of the chain, if the index is outside, then it'll cause an error. Or maybe if the chain isn't declared yet, it'll cause an error. In that case, it'll just pause it. So you can't mine it, it'll just pause and it'll go to the next one. And now, what does this do? While true, if block.hash, so 0 to self difficulty equals 0.self.difficulty, self.add block break else block.nonce plus equals 1. Very interesting. So what this does is, as we've stated before, it'll take the block and it'll calculate the hash for it. And once it does that, it'll take the index, so like everything, it'll like split the 64 length string into from 0 to self difficulty. And I believe we go up. Anytime a blockchain is created, the default value is just 2. So in this case, it'll be 2. Equals 0 times self.difficulty. So what does that mean? It just means it'll calculate the hash, it'll check the first two, I guess, characters, and see if they're both 0, right? That makes sense. And if they are, self.add block. So what does that do? It will add, sorry, hold on. Mine self block. Yeah, so it'll add it to the blockchain from here. There we are. So if the hash is equal, then it'll add to the blockchain. And if it isn't, it'll increase the block nuance by 1. And you might be asking, well, what does that do exactly? So the first time it calculates the hash and it doesn't work, then why would it then update the nuance plus 1? And to get that, we have to do a bit of explanation, but don't worry, it isn't too bad. So when you compute the hash, you will use the SHA-256 algorithm to compute the hash. And basically what the SHA-256 does is it'll take two arguments in this case, right? So what will happen is, let's say, we give, I'll just use some pseudocode. So compute hash. So first we'll have the data itself, right? So we'll have something like, do I still have that? I deleted it. It's alright. Well, that's something like this. So tip sends Tole 2 corn cobs. Yeah. Send 2 corn cobs, comma, and a nuance. Initially the nuance is 0. So I do that, right? And the output for this, interestingly enough, is a just a really long string, 64 length string. So something like maybe I mean, it'll have some numbers as well, obviously. Yeah, something like that, and it'll be I mean, the length will be 64, right? And be like, okay, that's cool. Now, in this case, it's looking for the first two to be 0, and clearly this is not 2 zeros. So it'll escape this bit, it'll like ignore this area because it isn't equal. It'll go here and increase the nuance by 1. And what does that do exactly? Well, let's have a look. If we increase this by 1, go up to 1, and let's say this was the output for when nuance is 0. If you move it up by 1, it'll give us something else. Give us a whole new randomized, it's not randomized, semi-randomized string, because it's all dependent on the data and stuff. And just for example, we'll do 2 zeros here, and again, and then somewhere 64. It'll check, it'll be like, okay, oh cool, 2 zeros, wonderful, we got it. And once they've done that, it'll add the block to the blockchain. Wonderful. You might be saying, well, what's the point of that? Well, it's just for security reasons, right? Because let's say you are a malicious actor and you want to make fraudulent transactions, and that would be not cool, right? If I were to allow you to run your own transactions without verifying them, you'd be able to just drain everyone of their corn cobs, and that would be kind of bad for the corn cob economy. So instead, what you have to do is run this compute hash, and once you find the required difficulty level of zeros, only then can you add the cob, I guess, the transaction of the cobs into the system. So obviously, with 2, it might be a bit easy to, you know, guess the required nuance for integer. But let's say if the difficulty is maybe 5, then it'll be much harder. So if you wanted to insert a false transaction, you would have to calculate the required nuance for the block hash to equal 0 times difficulty, and then you also have to do it before the legitimate transactions are able to, you know, verify that. And that would be difficult because once, let's say, we have a verified block inside the blockchain, and we add another one that's unverified, you'd have to do it before the second one is able to, or else it doesn't work, because these are all linked, by the way. I should have mentioned that earlier, but they're all linked. Again, if you go here, when you do update hashing, you might see this here. So for args and arg, right? Before I gave an example of just maybe like input data and the nuance, but realistically it'll also have the hash for the previous one. So it's dependent on the hashing of the previous block. So they're all linked in a sort of chain, hence a blockchain. So that is what provides security. You might be saying, well, what if I got a really powerful computer? The one that's even more powerful than whatever you're using to verify these transactions. Well, in that case, you would definitely be able to, you know, brute force it in. But what you must understand is, in a real network, these calculations are happening not only on one computer, but a whole host of computers that exist out in the world, right? So you'd have to compete against thousands of computers with your however many computers that you have. And realistically, it's very unlikely that you will just randomly guess the required nuance to verify your own block before the legitimate one is able to. So yeah. And now that we have gone through all the code, why don't we give this a run? Alrighty, so I'll start off easy. Make the the blockchain difficulty to 1. So just have to get 1 0. And if we run it, yep, okay, let's see what happened. Okay, I've got 4 blocks, and I wonder where that came from. Probably from here. So this is Hold on. Yep, so this is what I'm running right now. So when I run the program, it'll define all the functions and it'll run this bit right here. If name equals main, main. And this just means that, you know, if the file exists, basically, just run the code after. So we don't have to like worry about this bit. Anyway, so what is main? It defines a blockchain and it creates a database, and the data is A, B, C, and D. Interesting. And we've got a number equals 0, and for data in database, num plus equals 1, blockchain.mine block data num. Very strange. Okay. For block in blockchain.chain, print block. Print blockchain dot is valid. Okay. So what we're doing right now is for each letter in the database, it'll grab the letter in order and it'll mine the block. Basically, it'll try to insert it into the blockchain, right? And it'll verify it and it'll put it in. And if you remember correctly, we set the difficulty to 1, so it should be relatively easy to do. And after that, num gets incremented by 1, it'll go to the next one, so it'll be B, and it'll go verify that and insert it into the chain, and it'll do it all the way to D. And after that, for block in blockchain, print block. And if you remember from my explanation before, we've got a predefined print function right here. So anytime we try to print it, it'll instead run this formatted string that we've created. And after that, it'll just print a quick little check, blockchain.is valid or not, right? So let's see what our outputs are right here. So, okay, block 1, and our data is A. That's correct. It's all's in order. And our previous is 64 zeros. Okay, we expected that. The hash is 0E5424, continuing in other alphanumeric characters. Interesting. So we know A is being inserted correctly. And now time for block number 2. Data is B. Previous is the same as this here. Okay. And the hash is, again, starts with a 0. Very interesting. Okay, then after that, what's it done? It's done the same thing, so it'll go C, and this is the same as this one here. Sorry, and this is the same as this one here. So they're all linked. So we can check that they're linked, and all the starting values for the hash for the previous and the current are 1, 0 because we set difficulty at 1. And we can also print out the nonce value. So it shows us how many attempts the computer has made to get the 0 in the first spot, right? So for A, 19, B, 39, C, 44, 4, 22. So it doesn't take too long for a computer to do that. And this is all being run on CPU, so you know, do with that what you will. Usually these sort of computations happen on the GPU, so it's much faster. So to account for that, maybe let's increase the difficulty. So go here. I'm feeling a number 5 maybe. And let's delete this, delete that, give it a run. Taking a bit longer, and that is to be expected. Oh, there we go. And ooh, this does look promising. 5 zeros for the hash of the first block, 5 zeros second block, ooh, third, fourth, and they're all, if you look carefully right here, 0, 0, 0, 75, 75, right here, same. And the difficulty is scaling as well. So for number 1, it took 725,000. 725,000 roughly tries. This one, ooh, took 1,449,000. And yeah, this one almost 2 million. So if we scale this up like much higher, so what you gotta keep in mind is this is like it's like exponential scaling, I think. Maybe it's factorial. because the first one has 26 possible letters plus 0 to 9, so plus 9. And if we just go on a calculator, sorry guys, I'm losing my voice a bit, but here we go. 26 plus 9, 35, right? For the first character, times 35 again. So that's how many different combinations you can make. And again, if we do times 35, I think we get the picture. Again, 35. So how many have we done? So we've done 1, 2, 3, 4, I believe. Yeah. So you can see it scales up quite fast. And that's what provides the security, but also provides a lot of computational need. So that's also a bit of a concern in terms of cryptocurrency, is the fact that it takes so much power to compute these sort of things to keep it secure. But that's just the trade-off at the moment that we have. And well done. Now we've finally gotten to the end of our exploration of the code. And now, for the final punchline to this video. What can you do with these so-called coins, these cryptocurrencies? How are you going to make a billion money? Right? Our coin will be a C, because corn cob. I'll make C here, corn cob. I don't know how to draw cob, but I'll give it a shot. There we go. Corn cob. Corn cob. Cob. So let's say, as the sole owner of corn cob, you have 100% market cap, right? Like you are the market basically, and you can determine the market cap. What you can do is now create times a bajillion, or a million in this case, but a million. And then let's say you buy a coin for yourself for roughly $8. Technically, you are now the proud owner of $1 million worth of corn cob coin. Let's go! And now you can pay off your debts with your corn cob coin, guys. Let's go! Well, I mean, assuming that they, accept that as currency, and that's what my meme was about, by the way. When I sent the the crying cat, the emo cat, sorry, yeah. And thank you for coming to my TEDx talk. I hope this has been informative. I hope you've enjoyed this video. If you liked it, give it a heart, give it a share, and stick around if you want to see some more crazy, cool, wacky coding stuff. With that, I'll see you next time. Peace out.